Hello, in this session, we are going to discuss the extraction of sodium using the down cell electrolysis. Welcome. Sodium as a metal is an element of high reactivity. For that reason, it will not be suitable to extract it by the reduction method involving a furnace at high temperatures, simply because it will lead to explosions. The most convenient method, therefore, for extracting sodium as a metal of high reactivity is that of electrolysis. And the electrolytic process which is recommended is the down cell electrolysis. Now, when you look at sodium, sodium has a main ore known as rock salt. Rock salt is crystalline sodium chloride. There are other ores, namely sodium nitrate and trona, which is sodium bicarbonate. To be able to extract sodium from rock salt, we need to concentrate the rock salt by melting it so that it can be used as an electrolyte. However, the melting point of sodium chloride as rock salt is high and has to be lowered by treating it with calcium chloride. So calcium chloride lowers the melting point from 800 degrees Celsius to 600 degrees Celsius, a convenient temperature for electrolysis. Now, once we begin the electrolytic process, we find that the down cell is made up of an anode of carbon rod and a cathode of steel plate. Now, because of this, there is a steel diaphragm in between the anode and the cathode to prevent the anode reaction from interacting with the cathode reaction, so that there is no reversal of the reaction process. Next, how do the reactions proceed? We're going to look at it down here, just in brief. So, because the agent sodium chloride is made up of sodium and chloride ions, and the reducing agent calcium chloride, which lowers the temperatures, we find that there are three principal ions present: sodium, chloride, and calcium. Being positively charged, sodium and calcium ions shift to the cathode, while chloride ions shift to the anode, in principle of being negatively charged and attracted by the positive terminal. Next, the reaction which happens at the anode is an oxidation process where the chloride ions readily discharge 2 electrons, forming chlorine gas, and that process is complete as an oxidation process. At the cathode, because there are 2 principal ions, sodium and calcium, sodium takes preference in principle to its high concentration. It is readily reduced by the gaining of an electron and forms as a molten product, simply because the temperatures in the down cell are above its melting point. Once sodium has formed, it is tapped out at the top chamber, and when it is tapped out, it is collected as a molten product. After the sodium has been extracted, the remaining calcium will also be extracted, and in this case, the same reaction of a reduction will occur, forming calcium as a molten byproduct. However, the concentration of calcium is too low that it will not affect the substance which is the chief product in the down cell. So that is the down cell method of extraction of sodium by electrolysis. Next, we are going to look at what are the physical and chemical properties as well as applications of sodium. So coming down here, we need to look at the application in light to the properties, and we will say these properties. And next, we have the applications. So sodium as a metal is an alkaline metal. It is a substance which is soft and can be cut by the sharp edge of a guillotine. So soft and easy to cut. by the sharp edge of a guillotine. Number 2, it is malleable and highly soluble in water. It is also lustrous, which means shiny. How do you use sodium? When sodium is used in the manufacture of the amber glow in street lights. Number 2, it is used as a starting agent in the thermite process for extraction of gold. Starting agent in thermite processes. This is just because of its high reactivity. It is used in the manufacture of bleaching agents. For example, for paper pulp, you may have sodium chlorate. It is used for manufacture of teeth whiteners and many other applications. So that is sodium, an important metal. In a nuclear reactor, sodium combines with potassium to form the interior compartment for blocking nuclear radiations. So it can be used as a nuclear radiation absorbent. Good. So that is how sodium is extracted by the Downs cell electrolysis.